Hello everyone. Now that we have investigated a little bit about periodic phenomenon, what it is, and in particular the sine function, what we want to now be able to do is, if we have the graph of a particular child's sine function, can we actually find out what that equation will look like based upon the information that's given? So let's go ahead and just take a look at this particular example here. Here we have a sine function, and well, given what we have, it's a little difficult right now to actually determine what the equation will look like. But one thing that we do know is that the general sine function is going to be y is equal to a sine b times the quantity x minus c plus d. So we said that the amplitude is going to be the absolute value of a, 2 pi over b is going to be equal to the period, c is going to represent the horizontal translation, and d the vertical translation. So what that means then is that if I actually go about filling in this spot, that spot, that spot, and that spot with parameter values, then you basically established a particular child function equation, which will hopefully model this particular graph. Okay, so let's take a look at how we can do this. Now, one of the things that we want to go ahead and take a look at is, first of all, well, if this is going to be something similar to the sine function, one of the key elements is, where is the principal axis? If we go ahead and take a look at the principal axis, we said that if we go ahead and find y is equal to the y max plus the y min divided by 2, then what we'll do is we'll find that principal axis. So here I did this already, and it says it's y is equal to 3. So if I was to go ahead and do this, then basically that becomes the principal axis. And notice that what this really is, that represents what d is. Because what I'm doing is I'm taking that principal axis, which is usually on the x-axis, and I'm raising it 3 spaces up. So what that means then is that the p-value is actually 3. Given that the case, well, there you go. It's 3. Okay. Now, let's go ahead and take a look at the amplitude. Remember that we said that if we take the y max minus the y min divided by 2, then basically we're finding the distance from the principal axis to the maximum points on the function. So a is then going to be equal to 5 minus 1 divided by 2, which is going to be equal to 2, and that's going to be the a value. And notice that makes perfect sense here. If we go ahead and take a look at that distance from the principal axis, that's 2. And if I take a look at that distance from the principal axis, that is also going to be a value of 2. So what I know then is that the amplitude is going to be 2. Okay, there you go. Now, the other one is the period. Now the period is actually going to have to be decided upon by just taking a look at the information that is provided by the particular data that you have and the graph that is given. And I'm going to say, well, if I start here and I go up, and down, and I get to here, then this is going to be exactly the length of one period, and the smallest period that we have. Now, of course, it's going to continue that way. But what I can do is I can say that if we start at 2 and get to 6, then the period then must be 4. So if that's the case, the period has to be 4, and we know that the relationship between b and the period is going to be 2 pi over b, therefore b is going to be equal to pi over 2. So what I have now is I have pi over 2 here. Now the last thing that we have to go about doing is we have to take a look at what c is. And c, remember, we said is going to be the horizontal translation. Now, where are we going to translate to? If we think about what the parent function looks like, the parent function for sine actually starts at the origin. So in other words, what we're going to have to look for is we're going to have to look for that particular coordinate where the graph is actually increasing from the place where it intersects the principal axis. Because usually sine goes something like this, right? If we start off at 0, 0. So this corresponding coordinate for the parent function would actually be right here. So that means then that what I've actually done is I've shifted it over horizontally 2 units to the right, and then this would actually become essentially what I would consider the new origin if this was going to be the principal axis. So if that's the case, I can go ahead and say that there's a horizontal translation of 2, and therefore I can put this there. Okay, and there you go. You've actually found a particular child function, the equation of a particular child function, which is going to model a particular periodic phenomenon, which looks very similar to the sine graph. Okay, so there you go. You have the general sine function with all the different parameters. If you find those values of the parameters and you substitute it into the general form, you'll be able to go ahead and come out with an equation that should generally represent what is being modeled. Okay? Now, of course, what we're going to have to do is we'll play around with some verification techniques to see how close your model is. And that's going to be very easily done using your graphing calculator. So we'll take a look at how all that works out, and let's see if everybody can determine what those values of those 4 parameters will be, so that you can come out with a general sine function that represents a particular graph. Okay? Let's see how you do, and I'll see you in class next time. Bye-bye.